So we've already learned how to write electron configuration, and knowing that following the Aufbau principle, that electrons will occupy the lowest energy orbital first. And then we know, according to Hund's rule, there's going to be one electron in each orbital of equal energy before there's a second n. And then we're going to learn that the Pauli exclusion principle states that no two electrons can be in the exact same energy level, in the same subshell, in the same orbital, and have the same spin. And we can expand that to say that no two electrons have the same 4 quantum numbers. And what quantum numbers are used to do is basically provide an address for where an electron is within an atom. So these quantum numbers represent, the first one is n, which represents the energy level. And that starts at the first energy level and so on. Then we have this subshell, which is represented by the letter L, and that's basically used to describe whether it's an S, P, D, or F subshell. S is given the value 0, P is given the value 1, D is given the value 2, F is given the value 3. Then we can describe what orbital it's in using M sub L, which basically stands for the deviation from being the middle orbital within a subshell. So if we look at the 3D subshell, for example, the middle orbital would be given the designation 0, positive 1, positive 2. So this one's 2 away from the center in a positive direction. Going the other way from the center, this would be negative 1, and this would be negative 2. And lastly, we say the spin quantum number, represented by M sub S, is either going to be positive 1/2 or negative 1/2. And you can basically think of this as, if it's pointing up, then you would give it a positive 1/2 value. If it's pointing down, you'd give it a negative 1/2 value. So if we were writing the 4 quantum numbers for this electron, the outer electron in a bromine atom, we would say that it's in the 4th energy level, so n equals 4. We would say the subshell is the p subshell, which has a value of 1. Your M sub L is positive 1 because it's 1 away from the center. And then your spin quantum number is positive 1/2 because it's pointing up. So again, the Pauli exclusion principle states that no two electrons within an atom have the same 4 quantum numbers, basically meaning they can't exist in the same place at the same time doing the same thing.